Samo sekundu, molim vas, orkestar se štima, pa bih predložio da još jedno ovako kraće, slatko predavanje održimo. Veliko zadovoljstvo iz Rima, iz Talijanske nacionalne agencije za istraživanje i razvoj, i gospodin Alessio Ubertini, koji je naš sljedeći gost, i onda radimo pauzu. Evo, please, you can now. Vrlo zanimljivo predavanje, ja sam imao priliku pogledati nekoliko slajdova, odvešćemo vas od Egipta do From Egypt to Croatia, to RiScience. Thank you very much.
Hello everybody, thank you Sven for your invitation, and I would show you my presentation on virtual restoration and rapid prototyping applied to the cultural heritage. First of all, I have been working in Atenea, that is the Italian National Agency for New Technologies, Energy and Sustainable Economic Development. Now Enea as a new structure is distributed in about 9 research centers in Italy, and it has 3 big research departments for fusion and technologies for nuclear safety, energy technologies, sustainability of production and territorial systems. And it has also central units for administration and legal patent support and relationship with the other research center and agency in the world. In particular, I work in the Casaccia Research Center that is near Rome. I work in the Protolab laboratory that performs the innovation and the technology transfer activities to support SMEs in the CAD/CAM technologies sphere, and in particular with a special focus on rapid prototyping and reverse engineering technologies. Our area of interest are mechanic, biomedical, cultural heritage, industrial design, fashion industry, show industry, and goldsmith. This is a brief introduction on my lab. Then I go to the cultural heritage. First of all, in the biomedical sector, we developed rapid prototyping application in the production of functional and aesthetics processes, and we also developed an application for building 3D model from CAD data. Then we work with the fashion, accessories and jewelry sector, especially with the Arezzo district in Tuscany. That was the most important district in jewelry. First of all, is known for the made in Italy, and with providing training courses in 3D model, and with the development of application for innovative collection. And this the last picture is an example of, about what we can do using 3D CAD modeling and rapid prototyping. We use Rhinoceros as our CAD software. This is a mathematical function, the NPER function, and this is its definition in the plugin Grasshopper for Rhino. This is the prototype in resin, and this is the jewel. The jewel realized in gold on the NPER function shape. We also work in the industrial design sector for the development of CAD methodologies for the creation of model with a high level of design. These are pictures from our last course. And in particular, we use also in Grasshopper, we use the generative modeling. This is the mathematical definition of the Voronoi tessellation, and this is the Voronoi tessellation applied on a general surface. And this is the prototype. Then we work in the cultural heritage sector too, for the virtual restoration, for the reproduction of the archaeological found, also in the creation of copy for the museum bookshops. And now I want to show you two works about the cultural heritage. First of all, we use the reverse engineering, that is a non-disruptive technology that allows, by means of the use of a 3D laser scanner, to build the surface in a CAD environment, a surface of the object. A 3D scanner laser generates a laser beam that is reflected by the surface of the object. The drifted beam is captured by a CCD camera, and this reflected beam is converted in a point cloud, then by software in a polygonal mesh, and then in a CAD model. So from the original find, we have the copy, the virtual copy. Our methodology that we apply on this sector, the cultural heritage, starts from the find. Then we have the scan phase by using the laser scanner. Then there is a phase for data processing. The scans from multiple views are merged together to obtain the 3D virtual model. Then there is a geometry check to check the geometry of the model, and or eventually to modify it for the casting operation for the next steps. This is the virtual model. Then we have the step for the rapid prototyping. In the next works, we can see two kind of prototypation. We use rapid prototyping that are additive methodology. The model, the real model, is built layer by layer for deposition, and or using numerical control machine as a milling machine. That is a traditional methods, but is also used for with the new machine that are very fast. For example, this kind of machine are used to in Formula 1. This is a picture from the material addiction. This is the machine that we use, the multi-jet modeling, and this is the result. This is a traditional milling machine for building the copy of the statue. And this is the result. So, the first work is the Neptune statue in Bologna. That is, the aim of this project was to realize a copy, a reproduction to scale of the original statue that is placed in Piazza Maggiore in Bologna, that is known in the famous song of Lucio Dalla as Piazza Grande. And the copy was realized using the lost wax casting. We start from a scale marble model of the same artist, and then we have as our methodology says before, the realignment phase of the scans, the building of the 3D model, and this is the detail of the 3D model. Then we had an offset operation to have the right thickness of the statue, about 4 millimeters. And then we printed by using a multi-jet modeling technology with a thermoplastic resin that is similar to wax, just to use the lost wax casting for producing the copy. And this is detail of the object printed. These are some details. The square hole in the back, it was useful for for penetrating the bronze inside the statue. This is the features of the model. This is the placement of the sprues. And then there was placed some pins just over the surface of the model to avoid the relative movement between the different layers of coating in the lost wax casting. Here you can see the ceramic coating. Then there is the resin draining, so the resin came out from the mold. And this is the bronze casting phase. Then in the next slide, it's possible to see the result and the detail of the statue in bronze. Our another important, very important project was the project of the Pharaoh Home Horemheb. And this project was born from the collaboration of the Archaeological Museum and the Protolab laboratory. And the aim was to create a copy of two important reliefs from the Egyptian tombs of the General Horemheb and the Royal Battle Petumia. The General Horemheb, or the Pharaoh Horemheb, was the successor of Tutankhamun. The replicas in marble are placed inside the original tombs in Saqqara. The original reliefs are in the Museum Archeologico of Bologna. So, first of all, we did a planning phase at the Archaeological Museum with a portable equipment with these kind of features. And this is our laser scanner, and is a Minolta Vivid 900. Then we decided to create a template at low resolution to minimize the drifting effects in the realignment of the scan at high resolution due to the flatness of the relief. We have no information on the curvature about the relief. So we created this template. This is the our virtual template. Then we took about 100 scans at high resolution for each relief with this feature. And in this picture, more or less, it can be possible. It's possible to see the mesh density at high resolution. So this is on the left a picture of a detail of the relief. This is the virtual model of the detail. This is the realignment of the high resolution scans. We build the model just putting on the background the template in yellow and putting over the template the green scans in at high resolution, so that they wasn't constrained to respect the boundaries. So we start from the find, we obtain the virtual model, and we build the back of the relief by using NURBS, so 3D CAD modeling, because the back was just against the wall, so it was impossible to be scanned. And then we printed the copy using a 3D milling machine on Portuguese marble that was similar to the original material. And this is the result. This is the copy inside the Museum of Bologna. And this is the comparison between the copy, just on the floor, and the original relief. This is the tomb before our work. And this is the marble replica inside the original tomb. We did the same and applied the same methodology to the relief of Petumia. We built a 3D model, and we decided to extract the detail of this the 3D model, the face of this figure, and we decided to print to give an impression of the resolution to the archaeologist. We printed it by using a 3D printing system with powder or plaster injected by glue. This is the machine schema. This is the result of the printed detail. This is a picture of the detail. This is the milling phase for this relief. This part is completed, and this is in the building phase. And this is the relief in the original place. So the copy goes in the original place. So this kind of methodology can be used to, for example, to restore the damaged part of the relief, about, in particular in the corner, with the help of the archaeologists. There is There is a bird that is quite damaged, and that it can be restored by using the reverse modeler. It's also possible to have a virtual restoration of the color features on the virtual model. So, CAD/CAM technologies may contribute to the safeguard of the cultural heritage, building the copy to substitute the original find, as in our work, or to planning the restoration of a virtual model, like in this case. This is some phases of the virtual restoration of an arm of a statue, avoiding any kind of impact on the surface, on the original surface, or design a suitable packaging for transportation of the find, and also to create a copy to complete collection when the finds are in different places, or to for the diffusion of virtual model by means of the digital technology. So, for my presentation, that's all. Thank you for your kind attention. Thank you.
Grazie mille. Alessio.